Alright, so good morning. This is the last new topic that you're going to learn for your CDA. I would say the last 6 questions of your CDA deal with arithmetic sequences. So the word sequences, your first of your vocabulary on your notes, is simply an ordered list of numbers that often form a pattern. Okay, so I could do an example of a sequence and say, I don't know why I put brackets there because you don't have to have brackets for sequence. Let me just say the numbers 2, 4, 6, 8, and so on. So in most sequences, if they give you the sequence of numbers, there is a pattern in how you continue the sequence, okay? So the term of a sequence is simply each number in the list. So if I asked you for A1, this means I am asking you for the first number in this arithmetic sequence. And we're going to get to what arithmetic means down here, but they will always use A1 as the letter. Now they can change it and put T1 or N1, whatever the letter is. If it has a little 1 beside it, that means I'm asking you for the first number. So what would you say is the first number in the sequence that I created? A 2. What if I asked you for the fourth number in the sequence? And this is how I write it, A4. The little 4 tells you what number I'm asking you for. So the fourth number in the sequence would be 1, 2, 3, 4. So it would be an 8. Okay, so if this little 1 and A4 tells you which number in the sequence I'm looking for, okay, and your job is to find that number, and you're simply counting. This will be the first number, second, third, and fourth. Okay, so they're not asking you where is the number 2 in the sequence or where is the number 1. They're asking you for the position. Okay, now an arithmetic sequence is different from a regular sequence because you will have what is called a common difference, and the difference between the terms has to be the same in order for it to be a common difference. Now it just so happens that the sequence that I gave you is an arithmetic sequence. Okay, the common difference, or they're just going to use the letter D. What is the number that we have to use to continue the pattern? We have to add 2. Now, if you had to subtract 2 to continue the pattern, let's say I gave you the numbers in the reverse order, this would still be arithmetic. Arithmetic means you can continue the sequence by either adding or subtracting, okay? If you multiply or divide, it is not arithmetic. Only addition and subtraction work for an arithmetic sequence. Now, for this sequence that I just wrote with 8, 6, 4, and 2, I would say here the difference is -2 because the numbers are getting smaller, which means I had to subtract 2. So how you write the difference tells you whether you're adding 2, like we did in our first sequence, or whether you're subtracting 2, like we do in our second sequence. So the common difference is simply the number that continues the pattern. Okay? And that pattern has to work from the beginning to the end for all of the numbers. So you have to make sure that you check them all. Okay? So then you're going to be given 2 different formulas. They may ask you to write the formula in recursive form, or they may ask you to write it in explicit form. Okay? We use the explicit formula when you want to find a specific number in this sequence. So let's say we're looking at the sequence that I gave you above. Let's look at the first one. So I'm going to clear off the second one. So just looking at this sequence that I gave you above, if I asked you to find the 100th term, nobody wants to continue this pattern 100 times. Okay? So the explicit formula is a shortcut to finding the 100th term. So in here would be 100 because that's the term I'm asking you for. So you would say A100 equals, A1 means what is the first term in the sequence? Well, my first term in my sequence was the number 2. So I would put a 2 first down here in this pattern. Okay? So this right here would be the number 2. Plus, what is the number that we use to continue the pattern up there? Remember D, the common difference, this is the number that's used to continue the sequence. Well, in ours above, we had to add 2 each time to continue the pattern. So my D here was 2, and and here was the pattern. If I take 2 and I add 2 to it, I get 4. If I take 4 and I add 2, I get 6. So the D is 2. Alright, and then your N here would be 100. So it's always -1. That never changes. So I would simply type this in the calculator and it would give me my answer, which would give me the 100th term. So for example, 2 plus 2 parentheses 99, because that's what 100 minus 1 is, would give me 200. Okay, so notice what I put here. This is used to find any term in the sequence. So if I ask you to find the 1000th term, then you can use the first term goes first, the pattern number goes second, and N is whatever number I ask you to find. So if I ask you to find the 1000th term, N would be 1000. If I ask you to find the 50th term, N would be 50. Okay? Now the recursive formula just asks that you identify whatever the first number is. That's what the A1 means. Tell me what the first number in the pattern is. And then this part, A sub N equals A sub N minus 1 will stay the same. You will always have these two starting off the recursive formula. And you will simply plug in your D. So if I wrote my recursive formula with the pattern that we had above, I would say A1 equals 2, because that is the first number in my sequence. And then I would say A sub N, and make sure that you write this in small. It should be smaller than the A. It should be a little one, like a subscript. And then A, regular size A, little N minus 1, and it should be more towards the bottom of this number, okay? And then I'll put plus, and my pattern number was 2. And that's it. I have just written the recursive formula. So you tell me what the first number is. Keep A sub N equals A sub N minus 1. This will always be present, and you will never change any of the letters or numbers in these first two things. And then you will put whatever the pattern number is at the end. So if I'm adding 2, I put plus 2. If I'm subtracting 2 to continue the pattern, I would put minus 2. Okay? And that's it. So I know the formulas look like they're very hard, but they're very easy. Okay? So that's it. So long as you know what the letters A1, N, and D represent, you can plug into this formula and use it to find any number. So let's look at the opposite side and let's work with our arithmetic sequences. Okay, this should be a very easy lesson if you're paying attention. So if you're talking or laughing or joking right now, you need to stop it and you need to focus, because this is going to be on your CDA. Alright, so this question, example number 1, is the sequence arithmetic or not? If it is arithmetic, we need to find the common difference. Remember, common difference is simply the number that continues the pattern. Do you have to add 2 or do you have to subtract 2? If it is not an arithmetic sequence, then you need to explain. So let me just rewind for a second. Remember that an arithmetic sequence is when you continue the pattern with the same number. So every time I have to add 2 to get from one number to the next. If that number changes at any time, let's say I was adding 2 and then all of a sudden I had to add 10. If it changes to a 10, it is not arithmetic. Okay? So let's look at the pattern. How do we get from 3 to 8? Correct. We need to add 5. Alright? How do we get from 8 to 13? add 5 again. Very good. And I know it looks like the pattern is consistent, but we have to check all of them. How do we get from 13 to 15? Correct. So notice this time we changed the number. We added 5 on the first two, but we only added 2 on the last one, which means they do not have a common difference. It changes. So I would say this one is not arithmetic. Because the common difference, and I'm going to use CD to represent common difference because that's the first letter of the word common and the first letter of the word difference. So the common difference changed. So it is not arithmetic. If it's not arithmetic, you cannot tell me what the common difference is because they don't have a common difference. Okay? Let's look at number 2. How do we get from 20 to 200? Alright, so in this example we had to multiply by 10. Okay, 20 times 10 gives me 200. Remember, when you're multiplying with zeros, however many zeros you see gives you how many zeros you will have in your answer. So since 20 had 1 0 and 10 had 1, that gives me 200. Alright, now you notice we went from 200 to 2,000. We multiply by another 0 or by another 10. So would this be considered a common difference? The numbers are the same. Correct. No, this is not a common difference because of the simple fact that we're multiplying. And when you do an arithmetic sequence, you have to be either adding or subtracting. Anything else is not arithmetic. So I would put not arithmetic. And it said to explain why or why not. So because you are multiplying. Okay, and that's not allowed for it to be a common difference because you're multiplying. Okay, so now I want you to go ahead and try to work 3 and 4. Find the pattern, write it down, and then determine whether it is an arithmetic sequence or not. And Ms. Hall, you can pause the video. Alright, so I hope you actually went through and tried to work these by yourself. Let's see if you got the correct answer. So to get from 10 to 4, we have to subtract 6. To get from 4 to -2, I also have to subtract 6. To get from -2 to -8, I have to subtract 6. So this one is arithmetic. And my common difference is -6. So if it was arithmetic, I wanted you to simply tell me what the common difference was. What is the number that continues the pattern? As you see, we wrote -6 under all of these, so that is the common difference. That's the number I would use to continue the pattern. Alright, so number 4, we look and we have to add 4. To get from 13 to 17, I also have to add 4. To get from 17 to 25, I have to add 8. So this one is not arithmetic because the common difference is not the same. Alright, so that's it for example 1. Example 2. Find the next 2 terms of the sequence. A, you need to determine if it is an arithmetic sequence. And then B, write the recursive formula, then find the next 2 terms. So let's make sure that this is arithmetic. Let's do A first. Is this pattern arithmetic? What is the number that we use to get from 3 to 6? Plus 3. Remember, for it to be arithmetic, you're either adding or subtracting by the same number all the way through. So to get from 6 to 9, we add 3. To get from 9 to 12, we add 3. So since we're adding 3 each time, is this pattern an arithmetic sequence? Yes. Now we have to write the recursive formula. So recursive formula, I'm just going to write up here. You have it on the opposite side of your paper. But to write it, we're going to tell what the first term is. And then we get a sub n equals a sub n minus 1. Remember, this part always stays the same. And the only part that you will add in will be either plus or minus your common difference. Okay? So you have to tell me whether it's going to be positive or negative and what is your d. That's going to depend on whether you had to add or subtract your d. And a1 is the first number. Okay? So now that we have the formula set up on this side, let's fill it in. So a sub 1, for my example, remember the 1 means what is the first term? 3. Alright, then we will have a sub n equals a sub n minus 1. And what is our common difference? It is plus 3. Remember, common difference is the number that we use to continue the pattern. So since I can have either a plus or a minus sign, we are adding, so I put plus 3. And that's it for writing the recursive formula. Alright, now we're going to use the recursive formula to find the next two terms. So all we're doing is taking the last number that we have, which is 12. That's what a sub n minus 1 means. Take the previous term and add 3 to it. So what's the next number? 15. And the next number would be, take 15 and add 3 to it. We get 18. So these are the next two terms in my sequence. Alright, now let's look at number 6. For number 6, how do we get from 3 to 7? We add 4. How do we get from 7 to 11? We add 4. So this is an arithmetic sequence. Let's write the recursive formula. A1 equals what? 3. Because that is the first number in this sequence, and the number 1 means tell me what the first number is. Then we have a sub n equals a sub n minus 1. And what is our d? What number do we use to continue the pattern? 4. Very good. So we put plus 4. So you have to tell us whether you're adding or subtracting to continue the number. Now let's finish the pattern. So they left off at the number 11. So what would be the next number? 15. Very good. We took 11 and we added 4 to it. Alright, now what would be the next number? 15 plus 4 would give me 19. Very good. Alright, we can pause the video here. I would like for you to try 7 and 8 on your own. Alright, so I hope that you actually try to work these by yourself, because that is going to make sure that you understand how to work these problems and you're ready for your CDA. Now we're looking at negative numbers. So my negative numbers are going to a smaller negative number, which means we're subtracting because we're adding two negatives together to get a bigger negative, and we're subtracting 4. So you can test this out in your calculator. Negative 16 minus 4. An easy way to find the pattern is to take the the second number, and subtract it from the first number. So you're going to subtract backwards. Negative 20 minus negative 16, and you will get minus 4. Alright, what is the next number in the sequence? Minus 4. So this is an arithmetic sequence. Please excuse my cat. She's playing with her new toy and she's getting kind of loud. Okay? Okay, hold on. Let me go see what's going on. Alright, excuse me. I had to go rescue my cat. Alright, so Now let's start. We know it's arithmetic because we're subtracting 4 on both sides. So my first term, what is the first number that you see in this sequence? Negative 16. Very good. Now we're going to write a sub n equals a sub n minus 1, because this is always here. It's just something you have to remember. And what is the number that we use to continue the pattern? Minus 4. So we need that subtraction sign to be there, and there has to be a 4 behind it. So because that's the number that continues the pattern. Now let's find the next two numbers in the pattern. So if we start at negative 24 and we subtract 4, the next number will be negative 28. Now let's start with negative 28 and continue the pattern. We will have negative 32. Alright, so we're done. Make sure on these type of problems, when you look at your worksheet, that you are answering every single part of the problem. Okay? So now we look at 8. In order to get to from 1/2 to 1/4, we had to divide by 2. In order to get to from 1/4 to 1/8, we had to also divide by 2 or multiply by 1/2. Remember, multiplying by 1/2 and dividing by 2 are the same things. Either way, we are multiplying and dividing to continue this sequence, which means it is not arithmetic. Alright, and that concludes the first video, or the first portion of your new lesson for today.